Welcome and hello. Today I would like to present a topic called carbonyl compound. Let's get started, shall we? What are aldehydes and ketones? Well, aldehydes and ketones are carbonyl compounds which contain carbonyl group, a carbon-oxygen double bond. The functional group of aldehydes and ketones are the carbonyl group. Aldehydes. Its general formula is RCHO. In aldehydes, the carbonyl group has a hydrogen attached to it together with either a second hydrogen atom like a methanol, for example, or a hydrocarbon group which might be an alkyl group like the ethanol, or one containing a benzene ring like the benzaldehyde. Ketones. Its general formula is RCOR. In ketones, the carbonyl group has two hydrocarbon groups attached. These can either be alkyl groups like the propanol or ones containing benzene rings like the phenyltanol. Ketones never have a hydrogen atom attached to the carbonyl group. These are the iocide nomenclature. For aldehydes, it will change the suffix "e" of the parent alkane to "al", but for the ketones, it will change the suffix "e" of the parent alkane to "1". They both have the same general formula, which is CnH2nO. For an example, like propanol and 2-propanol. Note that the numbering must start with CHO as carbon number 1 or the nearest to number 1. Next is the physical properties. First, at room temperature, only methanol exists as gas, while other simple aldehydes and ketones are colorless liquid. Next, the carbonyl compounds are polar due to the presence of carbonyl group C double bond O with oxygen being more negative. The third is the boiling point. Boiling points of carbonyl compounds are higher than hydrocarbons because they are polar and have stronger permanent dipole interactions, but their boiling points are lower than amines, alcohols, and carboxylic acids because carbonyl compounds are less polar. The fourth is solubility. Carbonyl compounds, which are less than 4 carbons of carbonyl compounds, are soluble in water because they can form hydrogen bonds with water molecules. However, carbonyl compounds lack of hydrogen atom that can form hydrogen bond with oxygen atom of water molecules. Thus, they are less soluble in water. There are three ways for the preparation of aldehydes and ketones. The first is oxidation of alcohols, next is the ozonolysis of alkenes, last is the Van Craft acylation of benzene. Oxidations of alcohols. First, the oxidizing agent to prepare aldehydes from primary alcohols is pyridium chloramide, or also known as PCC in dichloromethane. Second, the oxidizing agents to prepare ketones from secondary alcohols is potassium manganate in warm acidic solution. Third, by using potassium dichromate in warm acidic solution. The red picture is the preparation of aldehyde and ketone. Next is the ozonolysis of alkenes. As we can see, the double bond from the carbons will be broken and each of the compounds will be attached to an oxygen that will form an aldehyde. Same process goes to the preparation of ketone. The double bond from the carbons will be broken and each of the carbons will be attached to an oxygen that will form a ketone. Van Craft acylation of benzene. Aromatic ketone can be synthesized from acylation reaction involving benzene with acid chloride or acid anhydride in the presence of AsCl3 as catalyst. The picture on the right shows off an example on how preparation occurs. Next, there are four reactions of carbonyl compounds, which is reduction, oxidation, nucleophilic addition, and condensation. For reduction, the reducing agents are: first, lithium aluminum hydride in acidic in ether; second, sodium borohydride in methanol; third, nickel with hydrogen 180 degrees Celsius. Aldehydes are reduced to primary alcohols. Ketones are reduced to secondary alcohols. For oxidation, the oxidizing agents are acidified potassium manganate, acidified potassium dichromate, Fehling's reagent, Tollens reagent, also known as the silver mirror test, and thiodomethane, also known as the iodoform test. Next, the nucleophilic addition reactions. Carbonyl group is polar due to oxygen atom is more electronegative than carbon atom. Thus, the carbonyl compound is electron deficient and susceptible to be attacked by nucleophile, and oxygen atom is susceptible to be attacked by electrophiles. The most typical reactions of the carbonyl group are nucleophilic addition reactions, which is nucleophilic addition of hydrogen cyanide, nucleophilic addition of sodium bisulfite, nucleophilic addition of water, nucleophilic addition of alcohols, and nucleophilic addition of Grignard reagents. Last is recondensation with ammonia derivatives. Carbonyl compounds can react with NH3 derivatives H2N bonded with R to form a compound containing imine group. In addition, with the removal of water molecule. Below is an example of how the reaction occurs. Applications of carbonyl compounds in our daily life. Propanol is used in such as industrial solvents in paints, varnishes, and nail polish removers. Methanol is used for several things such as preserving an environment, manufacturing plastic coatings, and polymer adhesives. Benzaldehyde and heptanoate are used for flavorings. That is all from me. Thank you.